हो गया कट कर दूंगा ना।
So this is lecture number one on soft computing, and in this lecture, this is the first lecture. So in first lecture we will be making a discussion on the introduction of soft computing. So the discussion in soft computing, we are having the first word that is soft, and the second word is computing. So essentially, we will start with the notion of computing, and to discuss that, let us make a discussion on the concept of computation. So, computation or computing, we are having an antecedent and we are having a consequent. Antecedent, it is essentially the input, and consequent, it is the output. Computing, we are having the system which is going to take the input and transform it into an output. So you can see an oval shape where computing is written. Y is representing the output or the consequent. F is the mapping function and x is the input. So f, which is the mapping function, it is sometimes also called the formal method, or sometimes you may term it as an algorithm, which is essentially making a transformation of the input into an output. So that is the basic notion of computation. Then, what are the major characteristics, important characteristics that which you are thinking of in computing? So there are three basic things. The first thing is it should provide precise solution. What does it mean? It means that for a particular input, for an input, there should be a particular output, precise solution. Then control action. Control action speaks of the set of steps that are going to get involved to transform the input that is given to the system into an output, and it should be unambiguous. It means that a single interpretation, it should be there. Multiple interpretation, multiple things, they are not allowed, and it must be accurate. So the first thing is it must be, it should provide precise solution. The second thing is control action should be unambiguous. Single interpretation should be there, and it should be accurate. Accuracy should be there. Then the third thing, suitable for problem, which is easy to model mathematically. So there should be an algorithm. You must be capable in when you are thinking of computing. There should be a mathematical model, or in other words, you can say that there should be an algorithm that can solve the problem. That is given. Then, coming to the third section in lecture number one, and that is hard computing. So, hard computing in 1996, it was proposed by a person. The name is Laz, and Laz, it stands for the computer scientists, they term him as Laz, and Laz, the full form is Lotfi Alexis Zade. He gave this in the year 1996. According to him, we can term a computing as hard computing if it comprises of three major things. The first thing, that precise result is guaranteed. It must give precise results. For an input, there should be a particular output. Control action is unambiguous. Again, what we just discussed is again over here. There are a set of steps. Control action speaks of a set of steps which are there in the algorithm, which transform. You are going to give the input and you are going to have a particular output, and it must be unambiguous. Single interpretation should be there. The third is control action is formally defined. That is with mathematical model or algorithm. We already made a discussion on that. There should be an algorithm to solve the problem. Then examples of hard computing. The various many examples are there, out of which we will be discussing three sections. The first section is solving numerical problems. When I say solving numerical problems, I am actually addressing the mathematical problems. Mathematical problems, various types, out of which two are given over here, that is calculating roots of polynomial, which is basically a mathematical problem or a numerical problem, finding out integration, derivation. All these are mathematical problems or numerical problems which we may consider as hard computing problems, as they comprise of the three set of characteristics that we already addressed in the previous section. Then searching and sorting techniques. For searching and sorting techniques, as we belong to the computer science background, so we already now soft computing we are studying in 7th semester. So we already studied a number of searching and sorting algorithms in data structure, and we are having an idea that there are algorithms, and algorithms there will be a set of steps. These algorithms, they are implemented making a utilization of different programming languages. So all in all, we are having softwares, and these softwares, they are actually having an implementation of algorithms, and these algorithms, they are basically meant for some searching activity, maybe sometimes for some sorting activities also. So we can categorize all those as in the hard computing category. Then solving computational geometry problems like the shortest tour in a graph, or finding closest pair of points given a set of points, geometrical problems. These problems could also be categorized in the category that is hard computing category. Now coming on to soft computing. Soft computing, as hard computing, the term, it was coined by Lotfi Alexis Zade or Laz in the year 1996. There are a few more technologies that which are coined by Laz, out of which one is soft computing, as well as before soft computing, he came up with another theory, that is fuzzy logic. So, the term soft computing was proposed by the inventor of fuzzy logic, Laz, already discussed. He described it as follows. The definition of soft computing In the words of Lass, soft computing is a collection of methodologies that aim to exploit the tolerance of imprecision and uncertainty. So you may see in the things that are written in the whiteboard, I have written tolerance of imprecision in black, uncertainty black, tractability, robustness, and low cost solution in black. So I'll first read out what the definition according to Lass of soft computing is. Soft computing is a collection of methodologies that aim to exploit the tolerance of imprecision and uncertainty to achieve tractability, robustness, and low solution cost. Its principal constituents are fuzzy logic, neurocomputing, and probabilistic reasoning. The role model for soft computing is human mind. I'll be coming on to this definition and I'll be focusing on what I wrote in black in the definition. The other things, the other set of words are written in blue. Some of the words they are written in black. So I'll be focusing on the words that are written in black, the contents that are written in black. Tolerance of imprecision. So, what you saw in the previous section, the characteristics of hard computing, precision, precise solution should be there. And here we are saying that imprecision is what you can have. So this is a feature that you may observe in soft computing. Besides that, you may see uncertainty. So uncertainty speaks of, now in different situations, you can have different outputs. That is what is not advocated in the previous hard computing, the characteristics of hard computing. You cannot think of uncertainty. Certainty should be there, but in soft computing you can think of uncertainty. Then tractability, yes, you want to have tractability when it comes to soft computing. Then robustness, robustness speaks of now input that which is given to the system that is supposed to be called as a soft computing system. It may comprise of noise. The system, it should be capable of handling the noise that is present in the input. And this feature is what is represented by means of the word robustness, low solution cost. Yes, you want solution and the solution, the cost that which is paid on behalf of getting that solution, it must be low. That is what you will observe in soft computing. And then going to the lower half, that which is written in blue, soft computing, it speaks of designing a framework that which is analogous to human mind. So then characteristics of soft computing. So these characteristics, four set of characteristics I have written. We are supposed to observe them in a soft computing system. When you are designing a soft computing system, it must be having, like we already discussed, what should be the properties or the characteristics that must be there in a hard computing system. Likewise, there must be a set of properties or characteristics that must be there in a soft computing system. So the list is already given. I'll be just the first one is it does not require any mathematical modeling of problem solving. In the other case, yes, you require algorithm, you require mathematical modeling. But here, you may not require it. Second, it may not yield precise solution. Already the definition speaks of the imprecision, tolerance to imprecision and uncertainty. So, that is already, I believe it is clear that it may not yield precise solution. Yes, it may yield, but it may not yield. So, the may factor is there. Third, algorithms are adaptive. That is, it can adjust to the change of dynamic environment. Flexibility. It speaks of the flexibility. When you think of a human being, as I already told you, that soft computing systems, they are mimicking human mind, and human mind, it is flexible in nature. When it comes to a variety of problems that we solve in our day-to-day life, you will observe the flexibility, you will see the dynamism. So that is what you will observe in the soft computing system. Then use some biological inspired methodologies such as genetics, evolution, ants behavior, genetics and evolution. So there is one paradigm that is called genetic algorithm, and genetic algorithm will be having a small discussion on that. Although in the syllabus that which we are having, in that genetic algorithm is not covered, but a short part of it will be making a discussion of in our tour towards the various topics that which we'll be making a traversal of. So a short discussion will be having on genetic algorithm. Then the ants behavior is also not there in our syllabus. So you might have observed that the ants they follow a path, and actually there is a secretion of a substance that is called pheromone, and it is that substance that they secrete that makes them they actually are following that pheromone that is secreted by the first ant, and the second ant it follows that, and so we are actually able to see a line in which the ants they are traveling. So that behavior is what is implemented in soft computing. Now, beside that, particle swarming, you might have observed the sky. In the sky, birds they are flying. There is a pattern you might have observed. When a number of birds they are flying, you might have observed that there is a pattern that they follow when they fly. Bird flocking. So that is particle swarming, human nervous system. How the human nervous system it works. Soft computing, it makes a utilization of that also for making an implementation of a system that solves a problem, and it uses all these biologically inspired methodologies. Now, some examples of soft computing are given. So, three examples I have. You can observe in the whiteboard. So, in the first example, we are having a soft computing system, and there are different ways in which you can write A. Different people, they write A, the letter A, in different ways. Or if they are writing in Hindi, if they are writing suppose K, then different people, they write the letter, the Hindi letter or the English letter in different ways. So what soft computing system, handwritten character recognition system will do is it will take the input may be taken by a different person, and the character, as I already told you, handwriting it varies. So what the output will be, whatever in whatever way the person he has written the alphabet, the result will be what is desired. So A is written in different ways, and the output A is there. So this is what you can have via the means of artificial neural network. Artificial neural network, we are having in our syllabus, we will be having a prolonged discussion on that. So right now I'll be just describing it in briefly, and then later on we'll be having a prolonged discussion on that. Then you can think of a problem where several banks are there. A person he is having some money, and he want to invest that money in bank. Different banks, they give different interest rates, and what the person his desire is to invest money in the bank and to have maximum profit. So this problem, it could be solved using the evolutionary computing mechanism or the genetic algorithm technique. Using the genetic algorithm technique, we can solve this problem. The person, he could have maximum benefit out of the money. He will be investing the money and he will be having the maximum profit. Then another problem is there, another example of soft computing problem is there, robot movement. A robot is there, he is placed at some position and he is supposed to get to some other position, and from the initial position to the goal position there may be several obstacles that could be placed in between. So there should be, the robot, he has to find out a path out of the obstacles, and he is not supposed to touch any obstacle, and he is supposed to find out a path so that he can reach the destination. So this is a problem which could be solved by making a utilization of the technique, that is fuzzy logic. As I already told you, that Lotfi Alexis Zade, he gave this fuzzy logic theory, and in our syllabus we are having fuzzy logic, so we'll be having a discussion on that and a prolonged discussion. So in today's lecture we'll be having a short discussion, and then later on we'll be having a prolonged discussion. So how soft computing, how we can achieve soft computing? It is essentially, now we already discussed computing, then we discussed what all characteristics it must be there in computing, then we discussed hard computing, then we discussed the examples of hard computing, then we discussed the definition of soft computing, then we discussed the characteristics of soft computing, then we discussed the various examples of soft computing. Then the question comes, now these are the examples, how we can make an implementation of soft computing. So the three terminologies which are used, artificial neural network, genetic algorithm, and the third fuzzy logic, how they work, soft computing. These are the three ways you can make an implementation of soft computing. So the analogy will be making a discussion on how it actually operates. So how a student learns with a teacher. So how a student learns with a teacher? Now if you consider any lecture, the teacher, he asks a question and then he gives an answer. Asking the question, giving the answer. So when a question is asked, the student, he may be knowing the answer, he may not be knowing the answer. If he is not knowing the answer, then the teacher, he will be telling the answer. This is one way in which the student, he learns from the teacher. So you can consider the student as the system, and teacher another thing which is going to guide the overall learning procedure. So the teacher asks the questions and then tell the answer. The student is supposed to learn. Another way, the student asks the question, the teacher asks the question, and then after asking the question, he gives a hint. And then the student, he may be able to answer the question. Then the teacher, he observes the answer after hinting what answer he gives, and then he validates whether the answer that is given by the student is correct or incorrect, and accordingly he operates. That is another way in which student and teacher learning it take place. Now, after learning the topic, the teacher he teaches, the student he learns. Student is supposed to be the computational system. Student learns, after he learns, he stores all the knowledge in his brain. Now, after this knowledge, it goes into the brain or the memory, then he will be able to solve the problem. The problem that which already may be given to him, it may happen that a new problem may be given to him. So, algorithms are supposed to be adaptive. So, on the basis of what knowledge that which the student is having, a new problem it could come, and the student must be able to solve that problem based on what knowledge he is having. He may be having a problem that which he may not have solved earlier, or he may be encountering that problem for the first time, but when that problem it comes, the student must be able to solve that problem. So this is how the artificial neural network it operates. This is how the human brain works. And this is how the artificial neural network it operates. We'll be going into the detail of that, but right now, this is a brief abstract of how artificial neural network it goes. Then coming to the second section. So in the second section, we are supposed to select the best. In the word, from the word, we are supposed to select the best. The thing is, we are having a population that is a random population. Random population means whatever is available to us, that is what we will be making a concentration of. And then what we will be doing is, whatever population we are having, a random population we will be going for the reproduction, and then after reproduction we will be ranking the population and selects the superior individuals. So we are having a random population, we are going for reproduction, and then we are ranking and so that we can get the best population. Population, it is basically the solution. We are actually searching for the best solution. There could be several solutions. In the problem domain, there could be several solutions. And out of those several solutions, we are actually trying to find out the best one. So this is how you can go. So this is how genetic algorithm. So the formulation that we just had a discussion on is the genetic algorithm formulation. So the population, as I already told you, population is synonymous to solution. And selecting of superior solution is synonymous to exploring the optimal solution. So whatever the problem